Hey guys, welcome to another Eindcode tutorial. My name is Philip, and in this video I'm going to explain you how you can create a simple game in a Phaser framework and later publish it on a Facebook Instant Games. So without any further waiting, we can start. Let's open a terminals. In a case you're on a Windows, you can open your PowerShell. So let's open a terminals. And the first thing we need to download or clone the initial repository of the Phaser framework I have prepared for you. Alright, so let's open your browsers, please. And go to github.com, and please let's go to my GitHub repository. It should be called Phaser boilerplate or something like this. Phaser webpack boilerplate. Okay, so on this address, github.com/yerga99 Phaser webpack-boilerplate, you can get my GitHub repository. So simply let's click here on a code. And you can either download this project, so go ahead, you can simply download the zip folder, or you can clone my repository if you have a Git initialized. So simply click here to clone or to download it. Okay, and I will also include this downloadable file in the resources of this video. Okay, so let's go back to our terminals. And since I will clone it, I will initialize this command here to get this code. So I will go to my starting project, so cd Phaser, or you can create a folder for a Phaser if you want. You can create a folder by writing mkdir to create a folder. So mkdir space, the name of your folder, so new folder, let's say. Alright, then you will press the enter, this will create a folder for you, and then simply to navigate to this folder, you will just write the cd to change the directory, new folder, and this will lead you to the directory, okay? But I will go to my Phaser directory, and here I will clone the project. So simply git clone, I will paste it here, space, and I will name this project. So I will call it escape bombs or evade the bombs. Evade bombs. Okay, bombs. Let's press enter. This will start cloning my GitHub repository into evade bombs folder. After it's cloned, we can go simply to this project folder. So cd evade bombs. Alright, and when you're in this project folder, you can just simply run here npm install to install all of the dependencies of the project, and then we'll run npm run dev, and this will start up development server on localhost 8000 AD. Okay, so are there any requirements to follow this video? Yes, there are just a very simple requirements, just a basic JavaScript knowledge, and that's it. Alright, so we have our evade bombs initialized, we have installed all the dependencies. Now you can run here npm run dev. This will start up your development server on localhost 8000 AD. Then simply go to your browsers. I will close this one and we'll start working from this window. Not this one, but this one. Alright, so localhost 8000 AD. Localhost 8000 AD. And you can see here your initialized project. So just simply, we are displaying here a canvas, and into this canvas we are displaying image. Alright, so as I mentioned before, Phaser is a framework, is a JavaScript framework for creating a game. So it offers you all the infrastructure, all the functionalities you can use out of the box in order to create a really awesome game. So it provides you with the functionality to handle the graphics, to handle the lifecycle of your game, to create a game objects, to manipulate images, to render objects in your game, and so on. Alright, so we can finally open our projects. Choose your coding editor of your choice. I am going with the Visual Studio Code, so I will open it. And we will find here our project, okay? So let's open here, file, open. I'm locating my file in a Phaser folder, so I will go to Phaser folder. Alright, so Phaser folder, and a Phaser folder I should have an evade bombs folder, so we'll open it, and this is our initialized project, and we can take a look on it. And from this point on, I will go a little bit faster, so this will be not very long video, okay? So what is important for us here is simply src folder here. And in a src folder, you have an index.js file. This is the entry point of your Phaser game. What you can see here is that we are importing a Phaser, we are providing here initial config, and we are creating a game with this config we have provided here. So you can notice we are providing here width and the height. This is the width and the height of the canvas you can see here. Width is 800 pixels, height is 600 pixels. This is this image we see here. Not actually image, but this canvas, this area here you can see. All right. Okay, so what other informations we have here? Type phaser auto. So this is the type of the renderer we will use to render our game objects and the graphics by the phaser. And auto means that will detect renderer automatically, and default renderer is a WebGL renderer, so web graphics library that almost every new browser has already inside of their JavaScript code. So it's already included in JavaScript provided by the browser. So all the new browsers should have a WebGL for rendering graphics. So this type auto will usually find you WebGL for rendering of graphics. Physics, we are providing here plugin arcade. So this will provide you basic functionalities, how to manipulate physicalities in the game. So how to manipulate the gravity, how to manipulate the velocity, how these forces are applied to your game objects. So that's the basically plugin we will be using to manipulate the game objects and what physical forces will be applied to the game objects. You can see here gravity is on the y direction 200. We'll be talking about this later. All right, and the scene, the basic viewport, the active viewport you can see on your in your game. So these are basic scene. We have here only two lifecycle functions, specified, preload, and the create. All right, and here we are loading this image from assets folder, sky.png. You can find it here, sky.png. All right, this is image, and here we are creating this image. So in the preload function is called only once, and in a preload you are loading assets such as images. You can load also here videos or audio files and so on. And in a create, you will actually create the actual image to your game. You will provide it to, you will render it in your browser. All right, so yeah, let's start programming, guys. So let's remove everything from, everything. Let's remove the scene from here. Just leave here empty scene. We can remove everything from here. Okay, so from a scene, let's save this. Now you should see here only black canvas. Okay, 800, 600 pixels. And I will create our separated scene, okay, because I would like to make it nicer. So in the src folder, you will create a new folder. You will call it scenes. And in the scenes folder, you will create a new file and you will call it, by default, I'm usually calling my scene play scene. So play.js, because this will be our default scene where the client of our game will be playing the game. So play.js. You will import a phaser here. So import phaser from phaser. And then simply will create here a class. You will call it as you want, but I will call it a play scene. And you will extend here phaser.scenes. Or the phaser.scene singular. Now you will export by default this scene, so export default play scene, and we'll define here a couple of things. First, you will write here constructor, and in a constructor you have to call super constructor, so constructor of the class you're extending from, which is a phaser scene, and here you need to provide a key, basically identifier of your scene. So key as you want, I will call it simply play scene. Play scene like this. And I will get this play scene into our index.js file. So let's go to our index.js file and let's import here play scene. So import play scene from the scenes folder /play, and we'll provide this play scene into a scenes here. I will provide it as an array. You can also do it. In the case you have multiple scenes, you'll provide an array of a scene. So simply let's get here play scene. Perfect, so that's a play scene. We can go back and still just a blackness. We would like to load here image as we had it before, so our sky.png image. Simply as we had it in the previous implementation, we can define here lifecycle function. We have three basic lifecycle function: preload, which is called only once, and is called to preload all of the assets. Create, where you will create actual assets on the screen, is also called once. And also you have an update functionality, which is called every frame. All right, so in the preload you will load the asset. So we load here our asset. You can get it like this. You will write here simply this context. This context holds the context of the scenes, and on this context we have a lot of properties and the functions you can use. So we will use here load. We'll use here image function, and you will load the image. You will provide a key of the image. So once again, this is just the unique identifier for your image. We can call it simply sky, because this is a sky image, and we'll load here from the assets /sky.png. When you would like to display this image, you need to create it. So let's go to our create function and let's write here this.add.image, and it will provide here coordinates, and about these coordinates I will be talking very shortly. So 400 and 300. All right, 400 and 300, and it will provide here a key of the image you want to load. Since we are loading here a sky image, we would like to create a sky image. When you will save this, you will go to your browser, as you will see the sky image is loaded. And now I will explain you how this is loaded, okay? Or by we are inserting here it on the coordinates 400 and the 300, but let me get here tools for this so I can draw on the screen here and let's see it. All right, so coordinate system starting from the left top corner. Here is a coordinate 0, 0. We are going on the x-axis. We specify the canvas width of 800 pixels. So there is 800 pixels width. All right, so there is a position here of the 800 on the x direction, and here the down we are going. Actually, we'll use this tool here. We are going here 600. That's what we specified. 800 and 600. All right, so what is the middle of the image? Middle of the image is a coordinate 400 and a coordinate on the y-axis of a 300. So here is the image. Middle on the coordinates of the 400 and the 300 for a y-axis. Okay, so that's why we are loading this image here. You cannot see it now over this drawing, so it's a 400, 300. So image is inserted in the middle of the screen. So image looks like this, right? You're loading the sky image. By the way, sky image has the same width and the size and the height as your canvas. Okay, so this is a sky PNG. When you will check a sky PNG is a 800 times 600. And origin point of the image is in the middle of the image. So middle of the image is inserted in the coordinates of the 400 and the 300. So that's why it's taking the full width and the full height of the canvas, because it has the same dimensions 800, 600 as our canvas here. And it's inserted into 400, 300, so the entire image is displayed here. All right, so I will remove this, and you can also use a different coordinate system, or you can specify different origin point on the image. All right, so let me show it to you. Let's go back to our coding editors. All right, so we can specify here instead of 800, 400 and the 300, 0, 0. Now we will see the image will be inserted here. So the center point of the image is inserted on the 0, 0. All right, so you can imagine that the image is in the back now, and this is the right bottom corner of the image, because this on the 0, 0 is inserted center of the image. You can see this entire image is inserted here. But we can set a different origin point on the image. I told you that the origin point currently, actually that's not very nice drawing. Let me write here, this is your image. All right, I told you that the default origin point of the image is here. And this origin point on the image is defined like this, by the 0.5 system. This is defining the origin point of the image. All right, and I will explain you how the origin points are defined on the image. Here is the 0, 0 point of the image. When you're going to x on the half of the image, you are going 0.5, 0.5, 0. Here is the x is a 1, and y is a 0. Okay, so that's how you're defining origin points on the image. The left top corner is a coordinate 0, 0. Half of the image in the x is a 0.5, comma 0. All right, and x1 and the 0 on the y is here. This is the origin points on the image. We can try the same in opposite direction. So when you go the entire y direction of the 1 and the x0, so this will be 0.1, 0.1. Here the entire direction of the right of the 0.5 for the x direction, and the entire length of the image down, this will be 0.5, 0.51, and the entire length of the width of the image, so x direction to the right is a 1, and then down 1, so this is the 1, 1. Okay, so that's how you're defining origin points on the image. This is the x, and this is the y. When we are going to half wave of the image to the right, so we are going on the x direction, so x will be 0.5, y is in this case 0, here is the x1, here is the y0, here is the x0, here is the y1, and here is 0.51 and 1, okay? So I hope you get the point how you are defining the origin points of the image. And this, of course, yeah, this middle is 0.5, 0.5 here, and 0.5 here. Alright, so that's how you are defining origin points. Alright, so when you will define coordinates as I define them here, 0, 0, so inserting the image here, you need to define the origin point on the image, so you write here set origin of 0, 0. So also the origin point of your image will be 0, 0, so left top corner, so this will insert also image on the full canvas. Alright guys, so I hope this is not very off topic for you, but I find it very important to define the origin points on the image and that you have an orientation on the canvas. You know where is a starting origin point on the canvas and then is a starting point, origin point on the image itself. Alright, we can continue and we can start loading the player into our game and then we'll explain the update function. Alright, so to load the player will be very simple. In the assets folder you can find the player .png, or actually we don't have here player. We'll use here, let's say bird.png, or I will rename this bird for a player. Okay, so rename player.png and simply have a simple task for you. In a preload you can load the image of the player. We'll provide a key of the player, and in a create you will create a player, let's say in the middle of the image here, in the middle of the canvas. Alright, so let's go ahead. I will simply copy this line here. I'll paste it under. I will provide here a key of the player, and on the assets, the path to the file, which is assets/player.png, and here we'll load it. So I'll write here this add.image in the middle of the canvas, so 400, 300. Let's provide here a key of the player, and that's it. Okay, now when you will see here, we are loading the player in the middle of screen. Okay, so let's take a look now on the update function. I told you update is called on every frame and you are displaying 60 frames per second by default. It's roughly 60 frames per second, okay? So your game is re-rendered 60 times, so 60 FPS is a 60 frames per second. This means also the update is called 60 times, okay? So update 60 times per second update is called. Alright, and in update you are getting the two values. You are getting here a time and a delta time. Time and a delta time. Delta time, maybe write it here, time, is a overall time in which update is called. I will debug it for you. We'll see what we are getting here. And delta is time from the last frame. Okay, so we will write here first. I will console log here the delta or time. Let's console log here time from which our game will start and update will be executed. So you can see I will clear it out. Oops, console clear it out, and I will refresh my game, and you will see we are starting from a 0 second or from 1 second roughly, and we are going up here, and this time is in milliseconds. So this is basically the 2 seconds, 2.7 seconds, 3 seconds, 4 seconds. So this is the time from which the update was starting to be called. Okay, so this will get you actual time from which the update was called. So this is the 5 seconds from which I refresh my browser and I will refresh again. Okay, so this is the 2 seconds from refresh, this is the 3 seconds from refresh, 4 seconds from refresh, 6 seconds from refresh, and this get me this overall time. The delta time is a little bit different. Delta time is the time from the last frame. So let's see. This will be roughly 16.5, 60.6. So the time from the last frame. As I told you, your update function is called 60 times, 60 frames per second. So if you will provide it to a calculator, let's say 16.5 from the last frame times 60 frames, you will see you will get roughly 1 second, so 1000 milliseconds. Okay, so this is the delta time in a milliseconds from the last frame. Okay, so the time is the time from the last frame. Okay, so that's the update function. Since this function is called on every frame, we can utilize it for navigation of our player. Okay, we can provide here some control of the player. Since the update is called, we can check what what buttons on the keyboard are pressed, and then we can, according to these buttons, we can set to the player velocity. Okay, so velocity is just the basically speed in a direction. Okay, so we can set it to play the player velocity. Let's say when we'll press the right button, we would like to set the velocity of 200 to the right. When we'll press the upper key, we would like to set the 200 up here, okay? And we'll create a simple navigation of the player through the map. All right, so yeah, let's start with this. I will simply remove this console log and we will create this control. First, we need to get a member variable here of the cursor, so we can check on which key the player is pressing. So we'll write here simply member variable, we will call it this cursors. All right, and you will get here this input.keyboard, and you will call your function create cursor keys. This will get you cursors, and from cursors you can get the keys you are pressing. So you can get here const. You can destructurize from the cursors up arrow or up key, down key, left key, and the right key. So let's get it from the cursors. And then simply I can write here a bunch of the if statements, and I can check which cursor has been pressed. So if, let's say, up is down, okay, so if you are pressing the up key, okay, so if up is down, then let's write here else if the, let's say, down is down, okay, so if the down key on the keyboard is pressed, then let's write here else if the left is down, if the left is down, then another else if the right is down. All right, another key, otherwise we are not pressing any key, so else. So we'll stop here. All right, and we can verify this that we are pressing here with the, let's write here is a console log, pressing up key or holding up key, holding up key, and the same for a down key, but will be consoling log out here, consoling down key, holding down key. All right, back here. Now let's press here up key, and you will see I will be holding up key. When I will press the down key, holding down key. So now we can provide some movement to the player. All right, for this, we need to provide basic physical body to the player. When the player is loaded as an image, we cannot control the player's speed, we cannot control the player velocity, gravity, and we cannot apply the physical forces to the player. We need to load our player differently. Since we are providing here arcade physics, we can create this player as the arcade sprite object. Okay, so simply I will remove this at image and I will change it. I will create here a player which I will assign to the member variable, this player. And I will create it like this. This context, you will access here physics. You will call here at, and then sprite function. To the sprite function, you will provide the coordinates of the player, which is a 400, 300. So the same, that's the middle of the screen, and again a key of the sprite, which will be player as we had it before. Okay, so this sprite will have an image of the player we are still loading, so this will be this yellow square. Okay, but now to the player we can apply more forces. You can see now the player is falling down immediately. So what is happening? What is happening is that we are applying force of the gravity to the player as soon as it's loaded to our map, to our game. This force you can find in index.js, where you see we are providing gravity of the 200. This gravity means the force which will be applied in the y direction to the game object, to all of the game objects in the scene. This means that our object will accelerate 200 pixels per second. So in a time of the 1 second, the object will be moving 200 pixels per second. Okay, so this means I will provide it for a second 0, so we're not applying any gravity. So you'll see our object is stationary here. But if you would provide a gravity of 200, this means your game object would be speeding up 200 pixels per second. So in a time of the 1 second, you would go 200 pixels per second. Oops, let me write it. In the time of the 1 second, you would go 200 pixels. In the 2 seconds, you would go 400 pixels. And so on. In the 3 seconds, you would go 600 pixels per second and so on. So that's the speed. You can verify it also when you will console log the information of this. Let me disable this tool. When you will disable it in your update function, let's say your player, so let's write here this player, you can access your body of the player and you can get here velocity in the y direction, or just a velocity. Okay, this should get me a velocity, and let's console log it out. Okay, so console log this player velocity, and can we access here on the y direction? Yeah, on the y, like this. This player velocity on the y direction, because the basically speed of the player, which is stationary now, you can see it's 0 all the time. When I will provide the gravity to the player 200, you will see in the time of the 1 second, our player will go 200, seconds, 400, you can see 1 is 200, 2 is a 400, 3 is a 600, 4 is a 800, and so on. So that's how the object is speeding up, but of course we don't have a control of this object, so this object is just falling freely, just out of the bounds of our game. Okay, so that's the simply gravity force. I hope now it's clear, so I'll move it back to the 0. Okay, so our object is staying nicely stationary up here. But now we can provide some velocity when we are pressing the keys. So whenever we'll press the, let's say, whenever we'll press here the right key, we will provide a velocity in the x direction, let's say 200 pixels. Okay, so this should create some speed to the player, which will be 200 pixels. So the player will be moving 200 pixels per second to the right. When I will press the upper key, I will be moving, we will provide here, let's say, minus 200 pixels per second speed. Why minus? Because our coordinates going from up to bottom. So here is the coordinate 600. When we go to up, we need to provide a minus. So 600 minus 200, so we are going up. So when you want to go down, you need to provide a positive velocity on the y direction. When you are going up, you need to provide a negative. All right. So let's provide some velocity to our game object. Let's go back. All right, to our play, and let's do it. All right, so here we have a up is down, and we'll provide here velocity. So I will access here this player, and I will set here velocity. Set velocity. Why we don't have access to the velocity? Give a second. This player dot set. Oh, here it is. Set velocity on the y direction. Okay, so we want to, when we are pressing up key, we want to go up. So we'll provide here negative value of some speed. So I will keep the speed in the separate variable. Let's go up to the create, and I will create here local variable, number variable of speed, or a player speed, or just simply speed, and I will get here value, let's say 500 pixels per second. This value I will apply to the set velocity on the y, so minus this speed. Alright, and the velocity on the x direction will be in this case 0, okay, because we are moving only up. Okay, so here will be velocity on the x direction will be 0. Okay, you can set it also in the one-liner. We will call here just this player set velocity, and here you can provide the object where you will provide the x, and on the y it will be minus the speed, and on the x you will have a 0. You want to write it as with a one function like this, and let's try it out. Okay, so let's go back to our browsers. Let's press the up key in the game. Okay, and actually we have disappeared, so we have maybe some error. Oh, okay, we are not defining any velocity to the player. Okay, it's none. Okay, so let's go back and fix it. Or let's see what the set velocity expecting from us. Set velocity expecting from us to set the value of the x and the y. So these two separate values, not the one value as the object as I provided here. So my mistake, first you need to provide the x direction. It will be 0, and then y direction, this will be minus this speed on the y direction. Alright, now let's save this, and it should work. So now when I will provide the right key, up key, I should go up, but I cannot stop it, okay? When I will press it 1, we are going just up, out of the bounds of the game. So we need to also provide here our default case when we are not pressing anything. So simply when we are not pressing anything, so in an else statement here, I will say here this player set velocity on the 0, 0. Okay, so now when I will just press key, I will go 200, but when I will stop it, when I'm not pressing the key, it will go back to the velocity of the 0, so it will stop. Okay, so now I can go upper direction. Okay, and now assignment for you, you can fill up the other else if statement. So when we are holding the down key, left key, and the right key with this player set velocity and the different speeds you need to apply. Alright, so we'll copy everything. Alright, oops. I'll paste this and we'll go to player is down. So when the player is down, when the down key is down. Okay, so when the down arrow we are pressing, we simply velocity on the y direction will be positive in this case, and the x direction will be 0. Alright, now for the right and the left, the y directions will be in this case 0, 0. And only the x direction will be changing. So when we are pressing the left, we need to increase the x. Oh, actually not increase, but we need to go to negative value, so minus this speed, and here we'll go to this speed. Alright. So now when I will refresh, we should be able to go on the map. Perfect, so this is working. Okay, so we can move on the map. Amazing. Alright, so just to recapitulate, so we have created this movement from to the four directions. So we are going up, down, right, and the left. We are setting velocity when we are going up. We are setting velocity on the y direction, so x direction is 0 velocity speed, and on the y direction we are going minus 500. Alright, here we are going 500. And on the y 0, here we are going minus 500 and the 0, and here we are going 0, 0 and 500. So that's how we are setting this velocity up, down, right, to the left. When we are not pressing anything, we are setting velocity of 0, 0, so our object is not moving any longer. Alright, so that's the basic navigation of the player, and now we can play our game. Perfect. Alright, one thing here, we can still go out of the bounds of our game, so I will fix this also. Let's go back to our coin editors, and simply enough, under the player, you can just simply access your player object, this.player, and you can set here set collider world bounds, and you will set it to a true, so you will be colliding with the world bounds of your game. So now when you will try to play it and you will reach the world bounds, you cannot just go through them. Okay, so these are player, and let's continue and let's create here some of the enemies. Okay, so for enemies I will use these bombs here. We have here bob.png, which is a simple image of the bomb we can use in our map. First I would like to provide a position of our player to be in the left top corner here, not the middle of the map. So in the left top corner I will spawn the player, and in the middle I will spawn the bombs. Alright, so player will be simple enough. We will just provide here coordinates 0, 0, and set origin of the player as well 0, 0. Set origin 0, 0. Alright, so player will be spawned here when we'll start the game, and now we can add here bombs. For this we'll load the image of the bomb, so under the sky I will paste it and I will load here bomb. So I will provide the key of the bomb, and this is coming from assets/bomb.png. Perfect, and in a create we'll create these bombs, but we'll be creating them differently as you are used to. These bombs will be sprites, that's true, but since we are spawning multiple bombs, we can utilize here groups. So groups is just simply from the name, as you can hear from the name, is the group of the game objects that you can define the properties. You can define the properties and functionalities on the group, and these functionalities will be provided to all of the members of the group. Okay, so simply group is the group of the game object with of the similar types. Alright, so under the player I will create these bombs. I will create here const bombs. You can see local variable. I'm not creating here member variable. And I will add here group. You can add a group like this.physics.add.group. Okay, this will add a group. So far we didn't do anything. We didn't spawn any groups to the map, because now we need to create the groups itself, create the bombs itself. You will simply call here bombs group and a function called create multiple. create multiple. In here, you need to provide a configuration object where you will provide a class type of the game object you would like to spawn. We will use here a spawn game object of type sprite. So the sprite we are creating here of the player. When you will hover over, you can see the type of this is a phaser.physics.arcade.sprite. So our class type will be the same. It will be phaser.physics.arcade.sprite. Then you will provide here quantity. So how many game objects you would like to spawn. I'll write here quantity of the 5 game objects for now. Then you will provide a key, all right, of this sprite. I will provide here a key of the bomb. So this sprite game object will be associated with this image here, bomb.png, because we are providing here a key of the bomb. All right, so this is a key of the bomb. You will mark it as an active. Okay, you'll write here active true. So this means that this game object will be interacting with your game. When object has an active of true, this means that the internal update function of the object is called. As soon as you will call here false, the internal update function of the game object will be not called. Okay, but about this, let's talk later, yeah. So basically you will say here active true. All right, and then set x and the y, so coordinates where you would like to spawn this object, let's say middle of the map. So 400 for x, and then for y, you will set here 300. All right, and that's it. Let's save this. Let's go back to our browsers, and you will see you have here 5 bombs. You can't really see it because these bombs are on top of each other, because you are providing coordinates 400, 300, so all of the 5 bombs are on the same coordinate. When you would like to step them, so each bomb is spawned on a different position, you will write here step x. So now the bomb will be, each bomb will be separated by, let's say, 20 pixels. Okay, so step x. And now you can see 5 bombs are next to each other. You will write here also step y. This will also step it to the y direction. Like this. Okay, so now we're spamming bombs like this. Okay, so we have our bombs. Now we would like to add some speed to these bombs. Okay, so how can we do it? If you would like to get a single bomb from this group, you need to simply get here, you need to get them through the function get children, like this. You will get here bombs, get children. All right, and then this will give you array of the bombs sprites. You will simply iterate over this group, over this array with a for each, and each iteration you will get a bomb. So let's provide here bomb anonymous function here in the for each. All right, now we can set here some physical guidelines to this bomb. So for example, we can set here velocity on the x direction and on the y direction. All right, so let me set it here. So let's access here bomb dot body and set velocity on the x. Okay, let's write it like this, set velocity, and we'll provide here the x and the y velocity. Okay, so let's start with the x velocity. Let's say we will start very simple. I will say here 500 and 500. Okay, let's see it. What will happen? Okay, so you can see all of these game objects going right here. We'll set here also collider world bounds for the bombs. So let's write here bombs set collider world bounds of the true. All right, oh, actually, I cannot do it like this. I thought I can, but I need to do it on every single bomb, I guess. So I'll write here bomb set collider world bounds. Okay, let's write it to a true. I will remove this one here. Okay, let's see. Okay, now they are colliding, perfect. It's working. Also, we don't need to access here explicitly body. We can do it also without the body, I guess, to set the velocity. It should be working. Yeah, you can see it's working. All right, and the other thing here, I would like to provide also some bounds to every bomb. So I will write here what bounds means. The bounds means that on collision, we will be bouncing out of the game object we are bouncing now, bouncing to. Actually, this will be simpler to explain an example. I will simply access the bomb and I will set here bounds. Set bounds of the one. Alright, so if you provide a set bounce of the 1, the opposite velocity will be provided on the bounce when you will hit the collider world bounce. Okay, you see you are bouncing from the edge by 1. If you provide a much higher world bounce, this will double the velocity on every bounce. Okay, so you can see when I bounce here, every bouncing is doubling the velocity, which we don't want. Similarly, when you will provide a lower bounce, each bounce will slower the velocity. Okay, you can see each bounce slowing the velocity. I'm going very slow now. Alright, so default set bounce will be 1. Also, what you can do, each of these functions returning the game object of the bomb, so you can simply chain this function into the one nice execution chain like this. Alright, and what we need to do now to randomize I would like to randomize the velocity that we are providing to this game object. You can get the range of the numbers with like this. You will get here phasor dot math dot between, and you will provide here a range from which you would like to get a number. Let's say -500 and the 500. The same I will provide for a y direction. Alright, so this will get me the random number in between of the -500 and 500. So this can be 200, 100, -300, -3, and so on. And the same for a y direction. So each of my bump will have a different velocity. Alright, so now you will see each of the bombs are going into the different direction. And we can even we could even increase the velocity of this game object. If you would like to have a harder game, you will provide a bigger range. Or you can also spawn more objects. You can, let's say, 25 of these bombs. And now you will have a lot of these game objects on the map. Alright, but the 5 as a default is fine. Okay, so now I would like to create a simple mechanic of my game. So every time I will collide with the game object, I would like to increase the score of the game. Okay, before we will start implementing this, let's go back and I will show you debug mode. Let's go to index.js, and index.js you can specify the debug property to be true. So in the arcade I can write here comma, and I can write here debug, and I will mark it as a true, and you will see visualized physical bodies of your game object. So you can see around every game object is this purple border, which is marking the body of the game object. So each of the game object you can see has this purple body. Okay, this collider, this is also colliders. When two game objects will collide, you can catch this colliding action, this colliding event. Alright, this can happen only between the object that has bodies. This green line, what you can see is the velocity of the game object. Okay, you can see the direction and also the speed in which we are moving. Alright, so now we need to set up the colliders between the player and the bombs. Alright, so let's go back to our coding editors. Let's go to play.js, and that will be pretty simple. Under the bombs get children, we'll write here new line of code, and I will access here this physics. So this physics at dot, and the function is called collider. To a collider function, you will provide a game object you would like to catch this collider on. So you would like to notice the collider, will be notified about the collider between this player and the bombs group. Okay, so bombs group and the player whenever they will collide. So whenever any member of the bombs group will collide with a player, I will execute here a callback function which I will provide as a third value here. Okay, and I will write here console log collision. Okay, let's save this. Now a few things will happen. You will see whenever I collide, I'm exchanging my velocity of the player into the bomb. You can see I can really bounce off the bomb from the player. You can see, and I can increase its velocity when I will collide with it. But the collision is now recorded, and you can see the bodies of these game objects are colliding. You can see also console log here that we are colliding, or actually we are displaying here these numbers still in the update. So I will remove this console log from somewhere. Console log collision, and here is the second console log in the update. So we'll remove it. Alright, so you can see on every collision, I'll display the collision in the console log collision, and so on. So now we can catch the collision between these game objects. Okay, I don't want to exchange any velocity between the player body and the bomb body. How can I do it? What we can do, we can simply access again the bomb and we can set it as an immovable. So set immovable, remove a comma and set immovable. Okay, it does not recognize this function for some reason, but you should have it set immovable of true. Set immovable. Okay, make sure it's spelled right. Okay, let's save this. Back here, and now when I will collide, we shouldn't be able to move this game object. Okay, you can see I cannot move the game object, only the bump is moving me. Okay, you can see I am getting moved by this game object. Perfect, but I cannot move the bomb. That's exactly what we would like, what we wanted to get done. All right, what I will do now, whenever I will collide with a bomb game object, I would like to respawn the player. I would like to respawn the player to the middle of the map, or the top right corner, or I would like to increase the score. Okay, that will be actually another condition. On the collision, spawn the player in the middle and decrease the score or increase the score. Okay, so let's spawn the player in the middle. That should be pretty straightforward. Instead of this collision, console log collision, we'll access here the player, so this player, and we'll set here X and the Y. So set X, all right, and we'll set X to be 400, which is the middle of the map on the X direction, and the set Y to 300, which is the middle on the Y direction. Okay, let's see it now. So now whenever we'll hit the bomb, we are getting spawned in the middle. You can see, getting spawned here, getting spawned in the middle, getting spawned in the middle, and so on. Okay, so what is left here to complete our game is just to keep the track of the score of the player. Alright, so let's try to do it. Let's go back to our calling editors. Alright, and first we can simplify these things here. I can set the origin on the same as I set the other properties of the game objects. I can chain them together. Execution of this function like this, set collider world bounds, and I will remove the semicolon. Okay, so it's cleaner. And then we would like to display the score in the top right corner. Okay, so in the top right corner we'll display the score of the game, or in the top left corner. Okay, it's up to you actually. I think I will display the score in the top left corner. I will spawn the player up here. Actually, doesn't really matter. Okay, let's see. Alright, so now to display the text. So under the speed here, I will create a text. I will save it to the member variable called this simply text. Yeah, this text, and you can create a text like this where you will provide the X and the Y coordinate on which you would like to display the text. Let's provide here 10, 10 as a basic coordinate, and then you will display number of the hits the player has been hit by the bomb. So hits, by default it will be 0, but because we are just starting the game, and then you will provide a configuration object of the font. You can specify the font size. Font size is the size in the pixels, so let's say 22 pixels like this, and the fill is the color in the hexadecimal format. So color will be black, or the white, so let's specify here FFF. Alright, so hash and the FFF, let's save this, let's go back to our browsers, and you will see now we are displaying here white color. I would like to display this text on the right. Okay, so how can we do it? What are the coordinates for the right bottom corner? Since the width of our map is 800, I will define here 800, and the Y will stay the 0. Okay, so now we are providing the image like this. I will drop it here. Okay, so X direction should be 800, so this is point of 800 on the X. On the Y this is 0, so this is 800 0. Okay, like this, but the text will be its origin point. I think it's in the case of a text, origin point is the top left corner, so text is somewhere here, so it's not visible. So we need to define the different origin or point of the image. Let's say the origin point of the image, so this is the text, you can imagine this as a text. Origin point will be, let's say, right top corner, so this corner here. Which origin point is this? So this is the entire length on the X direction, so X is 1 here, and the Y is the 0. So that's the origin point of this this corner here. All right, so I will remove this, hide this, and let's go back here and let's set here origin point of the text. I can make it on a new line and I will set here origin. So set origin 1 and 0. Okay, and now you can see now this origin point is here and we are displaying the text nicely. Or maybe we can indent it a little bit more to the left. So I'll just simply say here set 800 minus 10 pixels to the left. Okay, like this, and minus 10 pixels or plus 10 pixels down, like this. Okay, much better. And simply, we can just simply display here not 800 minus 10, but 790, and here will be just simply 10. Okay, so it will style like this. Don't forget, I found it really that students are getting confused by these origin points here, but it's now the image is here. And the origin point is we are setting to be here, right? This is the coordinate of 1, 0 of the origin point. So we are displaying image on the coordinate of 790 on the X, and from the Y direction is that is 10 pixels down. 10 pixels down here. Alright, so that's the origin point and that's how the image is displayed. Alright. Okay, so we are displaying hits. We need to keep track of them, so I will create here a variable. I will call it this hits. Alright, and now we need to increment the hits whenever we will collide with the enemies. So I will say here on the collision, whenever we will collide with the bomb, we will say here this hits plus plus. This will increment the hits and it will display a different text. It will display here this text. We'll reset the text. You can just call here function this text set text, and you will just change the text. So backticks here, and let's write here hits column and $sign curly brackets and this hits, and this will display the entire hits on the with the collisions 1, 2, 3, 4, 5, 6 and 7 and so on. So the point of our game is just to take the not as much hits as we can, but let's try to avoid the bombs. So lower score is better. The players with lower scores are better players, and when you have a super high score, you are a super bad player. Okay, and now you can increase the difficulty. You can say here, let's say 15 bombs. Okay, and now you are increasing the difficulty rapidly, and now you can need to avoid these bombs. And you can also remove the debug from the index. So let's comment it out. And yeah, that's basically it. Alright guys, so that should be it from our game. Now we are ready to publish this game on a Facebook Instant Games. So we need to do additional changes in the configuration. We need to prepare some configuration files, do some additional changes, load some things, and also sign up for a Facebook Instant Games. So I will leave it for a next part of this tutorial, and it should be much quicker to prepare this environment to publish it on the Facebook. Okay guys, so if you like this video, of course you can subscribe to get notified about my future videos, and do not forget on my platform I have much more full courses with lots of hours of content. So guys, I have to see you around.